Hi dear students, we are trying to study the slope of the different curves. In the last class, we derived a formula for calculating slope, which I said slope is equal to, if you remember, I wrote like this, delta y upon delta x, delta y upon delta x, which in turn we wrote like this, y2 minus y1 upon x2 minus x1. Now, today we shall see a little more detail on it. If I have a graph, say like this, and this is y axis, this is x axis, we already studied that the slope calculated on this line, for example, let me say that this is the value of x1, this is the value of y1, and here the corresponding value of x2 is y2, like this. And we tried to calculate the slope. We said slope is equal to y2 minus y1 upon x2 minus x1 is equal to delta y upon delta x. This is what I have written from the last class. Also, we saw that if the graph was a straight line, we can have any interval on x and a corresponding interval we are going to get on y. When we tried to calculate slope, we said that the slope was constant, or it was same for all intervals of x and y. So, what I am going to say a term is that as the x varies, y varies, but the variation is constant. So, when I get a straight line, I am going to say in this graph the variation is constant. Now, what I mean by variation is slope. Slope is constant, and I say that as variation is constant whenever my graph is a straight line. If I see another graph, say like this, I say this is y and this is x, and if I have a curve like this, we saw in the previous class that the slope calculated over different intervals of x kept on varying. Let me say this is x1 for me, this is x2 for me, this is y1, and the corresponding value of x2 is this one, y2. So, when I tried to calculate the slope, we said y2 minus y1 is equal to x2 minus x1, which is equal to, here too it is delta y upon delta x. Here the slope is equal to delta y by delta x. Here too I said the slope is equal to delta y by delta x, but both graphs are different. However, the expression that I wrote is same. So, primarily what makes the difference if I ask the question? I said here as the interval changes, the slope remains constant, and therefore I said variation is constant. However, if I change the value of the x, what I mean is if I change the interval, say this is x2 dash and here I have y2 dash, I know that the slope is going to change. For the interval between x1 and x2, the slope is different. For the interval between x1 and x2 dash, the slope is different. Slope I said variation. So, here variation is constant, here I say the variation itself is varying. Variation itself is varying. So, here I have varying variation. So, two types of graph. If it is a straight line, variation is constant, but here if I have a curve, I say varying variation, otherwise I would say that variation is varying. These two terms will give you a clue. So, variation is constant, variation is varying. When it is a straight line, constant. When it is a curve, the variation is varying. Now, when variation is constant, over any time interval the slope is constant. Therefore, over any small interval time or large time interval, the slope calculated will always be a average value. So, this is average variation. Say this is an average variation, average variation over a large time interval will be same as that of the variation at any instant at any single value. What I mean, average variation which is equal to y2 minus y1 upon x2 minus x1 will always be equal to y upon x. What I mean y upon x? For a given value of x, the corresponding value of y, even if I find the ratio, this is going to be same. However, here the case will be different. If I take one specific value, then the interval itself is 0. So, therefore, I will not be able to calculate the slope of the graph. Why I was able here? Because the slope is constant. So, at any point you say, for me the average value taken over any interval is same as that of the slope of the line at any particular value of x and y. However, here even a slight change in the intervals will change the slope. For that, I require to calculate slope two values y2, y1. So, then if I want to calculate the slope at any particular point, then what I need is I will have to bring the value of x1 and x2 as close as possible, else I will not be able to calculate the slope. So, to bring the value of x1 and x2 as closer and as close, then the slope will become more closer to the slope of the tangent drawn at this point. And mathematically, we say that to calculate the slope say at x2, so that slope at any particular value of x, then I would say that I am going to make the interval of x as small as possible, and I will write like this, delta y upon delta x. In that case, mathematically we write this value as dy by dx, dy by dx. So, therefore, this dy by dx will give me the value of the slope at any particular value of x. To do this, we say mathematically that this is the differentiation of y with respect to x, with respect to x. This is what we mathematically say. It means that if you have a curve, then to find the slope at any value of x, we need to differentiate the function. Whereas, if I have a straight line, to find the value of slope at any point of x, simply if I calculate the average value, that will be enough for me to calculate the slope. This is the prime difference. So, therefore, now to handle the graphs in physics, we are going to come across many a times a graph which will be of curve in nature, and therefore, very often or frequently we will need to calculate the slope at different values of x. In that case, we will have to deal with the differentiation concept. So, fundamentally, how we can differentiate the function, we should have the idea. So, let us move on to that topic. Yes, here we are trying to see the meaning of the word differentiation and how we calculate differentiation of a particular function. So, y is a function of x. I have drawn the graph, when the value of x is 1, the value of y is 2, 4, 6 and 8. Now, to calculate the slope, I said if it is a straight line, then the average value calculated, average value variation of y over x if I calculate. So, I am going to get my slope which is going to be equal to, let me take between this and this 3 and 1. So, therefore, x2 minus x1, corresponding value of 3 is 6 and corresponding value of 1 is 2. So, this is this 6 minus 2 and this is 4 by 2, which is 2 is the slope. Let me say the same slope I want to calculate for a particular value of x. I know slope is nothing but the expression is y2 minus y1 upon x2 minus x1. So, I need two values to calculate slope, but for the case of straight line I am going to see, I am going to take only one value, say 2, otherwise say 3. If I take only the value 3, so the value of x is 3 and the value of y is 6. So, if I take y by x, this time I am taking only one value of x and y. So, for y it is 6 and this is 3, once again I get 2. However, the formula for calculating slope is y2 minus y1. So, I should have two values at the numerator and at the denominator I should have two values, but I have taken only one values, again I am getting the slope same. Thirdly, what I am going to do is, I am going to use one technique. See, I have y is equal to 2x. So, for me the function. So, I am trying to calculate slope. When I try to calculate the slope, I have 2x. So, I have 2x power 1. Mathematically what I am going to do is, I am going to do like this, 2 times, I have the power, I am going to multiply the power over here, times x, I am going to subtract the power by 1. I am going to subtract the power which is already 1, I am subtracting 1 from it. So, 1 minus 1. So, I am going to have this as 2 times 1 is 2 x power 0, which is again 2. So, this was a simple technique that I used. Simply what I did is, the coefficient of x I kept as such, the power I multiplied with the coefficient. So, 2 times 1 times x I have already the power, I am subtracting 1 from power. So, 1 minus 1 I am having 0. So, 2 times x power 0, anything power 0 is 1. So, 2 times 1 is 2. So, I see that the slope calculated using this method is same as that of this. Now, the method of calculating slope like this, how? By multiplying the power to the coefficient of x and subtracting 1 from the power gives me the slope, and symbolically we write this method as dy by dx, whereas we write this method using del y by del x. Now, in physics whenever we will write like this, we say we are calculating the average value, and whenever we are calculating like this, we are going to say that we are calculating instantaneous value. We are going to calculate instantaneous value. This is the difference. Now, so this I took for a straight line. So, for a straight line, either I calculate the instantaneous value, or if I calculate the average value, both are going to remain same. However, in case of slope, this will be different. So, let us have a look at the different graph which is a curvature in nature. So, let us see for a curvature nature of graph, let me say that this is x, this is y, and I have a curve like this, say this is equal to y y is equal to 3 times x square. This is the curve which is described by this function or equation C. Now, to calculate the slope for a particular value of y, instantaneous value. So, this will be the slope of the tangent drawn at this point, right. To calculate the slope at this point, what actually we are going to do is, see, now I said the instantaneous slope will be calculated by differentiating the function dy by dx, which is equal to, I said this coefficient I am having times the power, I will multiply with the power, times x power, I am going to subtract 1 from the power, so 2 minus 1, which is going to be 6 times x power 1, which will be written as 6x. So, if I know that the slope is different for different value of x, right. As I change the value of x, the slope of the curve is different. Here the slope is along the tangent drawn here like this. This is the slope, and here this is the slope like this. Now, here this is equal to slope expression for me, which I derived from this value. So, here the slope is a function of x for me now. If we look at carefully, this is what we said slope. So, this slope is equal to 6x. So, if you look at this carefully, we say that the slope is function of x. It says that as the value of x is increasing, the slope is increasing, the slope increases. So, we have differentiated function y is equal to 3x square with respect to x, which we got like this. Let us have a look at another graph. So, the graph is a straight line, and for this, if you ask me what is the equation, then straight away y is equal to 4. Y is equal to 4. So, as you change the value of x, you say the value of y remains constant at 4. Now, if I am asked what is the slope of this line, so when I look at, I know that if I see slope is equal to, if I take two values, say this is x1 and x2 here. So, for x1 and x2 the value of y is same. So, I know y2 minus y1, x2 minus x1, the numerator value is same. So, therefore, the slope is 0. At any particular value of x, if I am going to calculate the slope, again I should get the 0. As such, if I use our technique dy by dx, which we said it is a slope, that means I am going to calculate the slope of a constant, which can even be written as d by dx of 4 times 1, or which in turn can be written as d by dx of 4 times x power 0, because I am differentiating this one and I know that anything power 0 is 1. So, 1 can be written this way, and the technique that we followed now to find the differentiation, I have the coefficient 4 times, I am going to multiply the power is 0 times power minus 1. Now, anything if I multiply by 0, I am going to get the result 0. So, thus from this concept we get, whenever we differentiate a constant, it always yields 0. So, therefore, the concept says that differentiation of a constant is 0. Differentiation of a constant is 0. So therefore, we can generalize our idea that if I have a function which is a, to me if a is a constant, then if I try to differentiate this value, I am going to have dy by dx, which is nothing but y is a constant. So differentiation of a constant is 0 for me. The second idea I say, if I have a function y is equal to a constant times x power n, and if I want to differentiate this one, so then I will have dy by dx is equal to coefficient times the power times subtract 1 from the power. So this is the generalization of our idea that we have developed from the graph. So let us try to solve one or two problems. Let me say that I have a function y is equal to say x cube plus 5x square minus 4. So this is a function, y is a function of x, and I am asked to differentiate. I am asked to differentiate the function. When I am asked to differentiate the function, it means that I am asked to find the slope, or I am asked to find the variation of variation. Whenever variation of variation comes, we try to differentiate. If variation is constant, we are sufficient if we calculate only the average value taken over large time interval. So in that case, dy by dx if I take, to me this is nothing but dy by dx of x cube plus 5x square minus 4. Else this can be written as d by dx of x cube plus d by dx of 5x square plus d by dx of, say it is minus 4 times constant. Now we know here coefficient is 1, and 1 times the power, which is equal to 3x power minus 1 leads to 2, 3x square plus 5 coefficient, power is 2, 5 times 2, which is going to be 10 for me. So this is 10 times x power minus 1, 2 minus 1 is 1, so I am not going to write anything here. Minus, I know that differentiation of a constant, conceptually you know that it is 0, otherwise this is nothing but 3x square plus 10x. So this is the differentiation of the function given to me. This is the differentiation. Similarly, as we have generalized these two cases, we often need to differentiate the trigonometric functions, which we need to remember. Rather, you are going to study differentiation of trigonometric concepts in mathematics in class 12th. However, we should have the idea of differentiating the trigonometric functions. So therefore, straight away, if I have the trigonometric function like this, y is equal to sine of x, and if I want to find the slope, or say I want to differentiate this one, so dy by dx is going to be cos x for me. So wherever I have sine x, if I need to differentiate, I am going to write it as cos x. If you want to understand the meaning sine x, then the function sine x varies like this. If this is x, this is y. Now this is nothing but slope. So therefore, if you try to plot the slope, at every point if you try to calculate the slope, here this is the slope, and at this point the slope is like this, at this point the slope is along the tangent, here the slope is like this, here the slope is like this. So slope of sine curve, so here the slope is maximum. So if I try to plot the slope, slope is maximum, and slope gradually decreases, and here the slope becomes 0. So gradually decreases, and here it becomes 0. Slope becomes 0. Then gradually the slope increases. The slope increases and becomes maximum here. So therefore, however, the slope is negative. Here the slope was positive, positive slope decreasing. So positive slope decreases. then from 0 onwards you see that slope is negative and becomes maximum here. The slope is negative and it becomes maximum. Then maximum slope is at this point, then slope decreases and becomes 0. So, slope decreases, negative slope decreases and becomes 0 at this point. Again here the positive slope increases and becomes maximum at this point. This is the case. And if I see what is this curve, this curve is nothing but cos x. So, this is cos x. So, I have plotted the slope of this curve which I am going to get cos x. This is the reason why I say if I have a function y is equal to sin x, when I try to plot the slope at every point of this sine curve, I am getting a curve like this which is nothing but cos x, and that is what we say dy by dx is equal to cos x. Similarly, if I have a function y is equal to cos x, then the differentiation of cos x is going to be minus sin x. You can try at home, just you plot the graph. So, say this is cos x, and if you try to plot the slope of this graph, see please here the slope is negative, it turns negative, that means here right at the peak it is 0, then it goes negative, here the negative slope is maximum. So, therefore, 0 slope is negative and becomes maximum, then slope decreases, further it becomes 0. So, negative slope decreases and further it becomes 0, then positive slope it goes, the positive slope is maximum at this point, the positive slope is maximum, further the slope reduces and it becomes 0 here. So, positive slope reduces and becomes 0. So, if you see this curve and this curve, this is sine curve, this is opposite of the sine curve, and therefore, we say the slope dy by dx is equal to minus sin x. So, therefore, slope of cos x, y is equal to cos x I have. So, I am trying to find dy by dx, that is I am trying to find the slope of this curve. So, slope of this curve at every point I am getting this curve, and this is nothing but negative of this curve. So, therefore, minus sin x, right. Similarly, y is equal to, if I have tan x, y is equal to tan x, and I am asked to calculate what is the slope. So, dy by dx, that is differentiation of tan x with respect to x is equal to sec square x. Similarly, if we have y is equal to cot x, then when we try to calculate the slope, dy by dx is equal to minus cosec square x. If I have y is equal to sec x, then dy by dx is equal to sec x tan x. And if I have y is equal to cosec x, then the slope that I am going to calculate dy by dx is equal to minus cosec x cot x, cosec x cot x. So, these things we need to keep in mind for solving the problems of physics. Similarly, we have one more important function that we will come across. If we have y is equal to e power x, which is an exponential function, and if I try to find the differentiation of exponential function with respect to x, the beautiful thing is that even the differentiation of exponential function is going to remain same. Dy by dx is equal to e power x for the function y is equal to e power x. Similarly, we may have a function y is equal to say u v. What is u v? I say that u is a function of x, v is also function of x. So, two functions. So, I would say that these are the product of two functions. So, in this case when I will differentiate this one like this using the formula dy by dx is equal to, what I am going to do, second function into first function differentiation. So, du by dx, first function into differentiation of, second function into differentiation of first plus first function into differentiation of second. Now you may ask, why sir, why not we write this term first and second this term? Of course you can write, but develop an habit of writing second function and differentiation of first function. You differentiate first this one, because in the quotient rule we will have denominator into differentiation of numerator, which I am going to say numerator as the first function and denominator as the second function. So thus when I have a function as the product of two functions, I will find differentiation like this. Similarly, we will have y is equal to u by v. So two functions of x I have, and the functions are like this, division of two functions. In that case, differentiation will be dy by dx is equal to, let me say this is first function, this is second function. So second function into differentiation of first, rather I would say denominator into differentiation of numerator minus numerator into differentiation of denominator over square of the denominator. So this is a formula to differentiate a function which is like this, u by v, and if I have product of two functions, then I will be using this formula. So dear students, let us stop today. In the next class, we are going to solve some problems based on the formula that we have derived here and based on the functions, all these trigonometric functions. In addition to that, we will see the concept of integration. Thank you very much.